Hello, thanks for sticking with Introduction to Programming in Python. This is our second video, and today we're going to tackle one of the most important foundational concepts in programming, and that's primitive data types. So by primitive, I mean that these data types are independent, simple, and single-purposed. Later, we're going to see more intricate data types, but they're all going to use these four building blocks exclusively, so it's important that we understand them. In Python, we've got four main sorts of data. That's integers, floats, booleans, and strings. In this video, we're focusing on numbers, and there's two ways to store numbers in a computer. That's with either integers or floats. First, an integer, which is typically abbreviated as int, is used to store any whole number value. If we want to store 4.2 instead of 42, we would need to use a float. And this would be a floating point value. It's any numeric value that has a fractional component specified. So if you write 6.0, you're specifying a fractional component. Now, normally in a programming language, it's the programmer's job to know when he wants an integer and when he wants a float, but Python actually is very nice. It's going to convert between these two without you really needing to do anything. We're still going to talk about it though, because you're going to find cases where integers are required or floats are required. Actually, Python will always convert integers to floats, but not always the other way around. So scratch that. We're going to find times that you definitely need integers and do not want floats. You might be wondering why we even have two of these types to keep track of in your head. Well, in reality, the computer stores all of its information as a series of ones and zeros. And that information, without any sort of context around it, is meaningless. For example, this binary string, or this binary sequence I have right here, without data types, we would not be able to actually understand how to interpret it. Is it text? Is it color? Is it sound? All of these things are stored as binary. If we say it's an integer, you'll be able to recover its number 42, but without a standardized way to decipher this, that binary string might as well not be there because we'll never get the information out of it. I'm going to have a whole other video about binary, so right now I'm just telling you why there's two of them, not really how we're using binary to get two of them. So we've got integers and floats, and you're probably wondering what we can do with them. So I'm just going to bring up idle right now, and we can start playing around with number operations. Although I know a lot of these seem familiar to most of you, or at least I hope. So before, we wrote a script, and that script said hello world. And a script is any file that ends in .py. And we're going to run it, and it's going to do all of the lines of code in sequence, and then stop. This shell, instead, is going to let us type individual commands, and we'll kind of get to interact as we're typing. So I'm going to print hello world right here, and we're going to see that hello world gets printed out to the screen. But I can also say something like 2 plus 2, and the result is going to get put out to the screen. It's important to clarify that if I actually wrote 2 plus 2 in a script, its result would not get printed out. But in order to kind of experiment with these number operations, this is a really quick and dirty way to test out Python code. So I just explained what addition does. Hopefully 2 plus 2 should have been easy for you. And 2 minus 2 is the same way, 0. I mean, you'll notice I messed up my spacing. It's important to note that the spacing between 2 minus 2 and 2 space minus space 2, there's no difference there. I'm also guessing that you can figure out multiplication for yourself. 5 times 9 is 49. And I'm hoping that you know 6 to the power of 9. No, I didn't know that off the top of my head, but if we want to say, 2 to the power of 5, that's 32. And we've got division, so we've got, 5 divided by 3 is 1.6 repeating. But imagine we just wanted the integer part. 5 divided by 3, but with integer division instead, will give us the number 1. Now, it's important to note here that integer division does not round to the nearest integer. So if we say, for example, 100, or if we say 99 out of 100, that's almost 1. If we say 99 divided by 100 with the integer division instead, it's 0, because it did not make it to 100. We just throw out whatever the fractional part is. This is normally referred to as truncation. We're truncating off all of the values after the decimal point. Now let's instead imagine we really cared about that remainder. We can use the modulo operator, 5 modulo 3. I did not type that. 5 modulo 3 in order to get the remainder. So we know that 3 divides 5 one time with a remainder of 2. So up until right now, I have been printing calculations just right to the screen, or in this case, I've been using the Python shell to kind of show the results of operations as we've been going. And that's not very useful. We have yet to actually store information in the computer. So we're going to do that with variables. So it's important that we come over here and talk about those. Variables are the names we give information. So if you remember algebra, you probably talked a lot about x. And x is a number that we're going to plug in or figure out later. And we can do the same thing while programming. So if I come back over to idle, I can say x is equal to 5. And now if I type x, we get 5. So we can, of course, print x, because x is a value like anything else. Amazingly, we get 5. And we can type x plus 3. Amazingly, we get 8, or not amazingly. So let's talk about that sentence x equals 5, or really that line of code. We can say x equals 5, but we can also say, and if we print out x, we get 5. We can also say x equals x plus 1. Now, if you remember your algebra, you'll probably say false. You cannot do that. X is not equal to x plus 1. But when we use the equal sign in programming, we're actually referring to assignment. So we don't say equal sign, we're going to say assignment operator. And the assignment operator takes something on the right-hand side. In that case, it's x plus 1. X plus 1 is the right-hand side. We're going to evaluate it. So we're going to look up x. X is 5. We're going to add 1 to 5. And then we've got the value of our right-hand side. And then we're going to copy that value into whatever is on the left-hand side. So in this case, if I say x is equal to x plus 1, now x is going to be 6. We can say y is equal to x plus 2, and now y is going to be 8. We can say z is equal to x plus y. Now z is equal to 14. And imagine if we say z is equal to z plus z plus z. Well, that would be the same as saying z is equal to z times 3. And I've actually bothered to print z. At this point we've got 126, but I really haven't been paying attention. So these names are great, x, y, and z, but if we have a really complicated program, we're going to want names that are much longer than one letter. So that's all about convention. Conventions are definitely not rules, or your code will run even if all of your variable names are awful. But as long as they're awfully consistent, the computer will be able to figure out what you're doing. But conventions are definitely important. So for example, if you were to drive a car on the wrong side of the street, you'd be fine as long as nobody else was driving around you, because your car's still gonna work. You're just not following the conventions. And yes, bad variable names are just as dangerous as car accidents. So the rule for our variable names is it has to start with a lowercase letter if it's a variable. So for example, if we were counting the number of apples, we can say, I don't have any apples, by saying apples equals 0. If I type apples later, we have none of them. If we got a new apple, is equal to apples plus 1. We just incremented the apples variable by getting an apple, and maybe it'll go away later. So you can imagine that our code is very often going to have these, x is equal to x plus 1, or x is equal to x divided by 1. There's a shorthand for that in Python. Apples plus equals 1 is a shorthand for apples equals apples plus 1. It's back up to 1. Now it's going to be 6. And if we wanted, a variable name with multiple letters, we can say, let's see, count of apples. And notice that how the beginning of each new word, I've got a capital letter. This is called a camel case by a lot of programmers. And it's just a way for your variable name to still be, one set of characters without spaces in there, but you can easily differentiate the words. Now, I didn't assign anything to it, so Python doesn't know what I wanted count of apples to be. But if I say it's equal to 0, and I do what I just did again, I let it know that count of apples actually has a value. And as long as you stay away from horrible variable names, your programming should actually be pretty easy to understand, or at least easy to understand once you've gotten a couple more of these concepts under your belt. Well, thank you for sitting with me for another one of these lectures. In the next couple of videos, we're going to study Booleans and strings.